Hello and welcome everyone. My name is Corey Lambertson with ASIGA, and I just want to thank everybody for joining our webinar today, and we're extremely excited for the webinar. We have a wonderful guest, Min Tran. If anybody is part of our ASIGA Dental Experts page, you'll actually recognize who Min Tran is. If you guys are a part of the 3Shape Experts pages, you'll be able to recognize him from there. And of course, you'll probably see him just from around the industry in general. And so first and foremost, I'd like to introduce Min. Min, go ahead and let's introduce yourself and we'll get started. I want to go ahead and read a bio for you real quick, and then we'll get started on what the presentation is today.
Hi, Corey. Thanks for the invitation. Thanks for the introduction.
Absolutely. So just a little bio on Min. So Min is actually a second generation dental technician. He's actually located in Windsor, Ontario, Canada. And so he's actually literally right across the border from where the US office for ASIGA is. He has 15 years of experience primarily in the CAD dental as a dental technician. And he was one of the first 3Shape users in Canada, and he brings a wealth of knowledge from that foundation. He's a lecturer, trainer, and has been a speaker, consultant, and technical advisor for multiple companies, including ourselves, ASIGA, 3Shape, Core 3D Centers North America, Full Contour, Pretty Denta, DAL, Abutment Direct, and the list goes on. So he has a vast knowledge of working with some major companies. He served on the program advisory committee for St. Clair College of his hometown Windsor, developed the new dental laboratory program there, which is phenomenal. And he's also a member of the American Prosthodontic Society and currently serves on the communications committee there. He's also the founder and creator of Dental Tech Tips, which is a great foundation. It's an online independent publication and blog focusing on unbiased product reviews and offering tips, tricks, and tutorials on the latest and greatest dental laboratory industry. I myself have frequented there just to learn and gain a little bit extra knowledge. So thank you, Min, for putting that on. And also thanks for braving the elements out. For anybody that's in the northern part of North America and East, we're getting slammed with a snowstorm. And so thank you for still taking the time and risking that to join this webinar with us.
Oh, it would have been done at home if it wasn't done at the lab. But there's always teeth that need to be made, right? So hopefully I get out of here before the real snow hits tonight.
Absolutely. Yeah, it's just starting to come down a little bit. So Min's presentation today, which is why everybody has joined, it's the actual course title is Smile Design to Printed Models and Increasing Case Acceptance with Digital Diagnostics. And so that is something I'm extremely excited to learn more about. And I feel like that's an area that all laboratories can improve on is showing that digital diagnostics for patients to rely on and really winning that case for the patient itself. And so, Min, I'm going to give you the floor, and also for here in a second, and for anybody and everybody that's watching, just to let you guys know, this course does qualify for CE. So if you're an RG or CDT, at the end of the course, we will send you out an email notification on how to get your credits for this. Also, if you have any questions about or during this webinar, please feel free to ask them, and then we'll go ahead and answer them all at the end as they come in. All right, man, it's all yours.
All right, thank you, Corey. I'm just going to go ahead and share my screen now. And I want to say, of course, thank you to ASIGA, thank you to Graham, the whole team over in Australia. As always, it's such an honor to be able and a privilege to be able to present for such a great company like ASIGA. We've really teamed up in the past many times and collaborated on some excellent projects, and it's such a wonderful company with such great products. I just enjoy using products so much, so I'm always taking any chance I can to say positive things about ASIGA. And like Corey had mentioned before, if any of you aren't already on Facebook groups, do join us on the ASIGA Dental Experts group. I'm privileged enough to be a moderator on there. There's so many skilled and wonderful people on there that are willing to share and collaborate and just present info, help each other out. Whether you're getting stuck, whether you want to present a case or something new or cool that you're just doing with your printer. So today, of course, we're going to be talking about smile design and digital diagnostics and how these tools can help to increase your case acceptance rates. So a little bit about myself. Corey already read my bio. I'm a second generation dental technician based out of Windsor, Ontario. spend most of my time behind a computer with a mouse and keyboard, primarily on 3Shade, but I've had been lucky enough to be able to use a wide variety of technologies. And in my spare time, of course, I run a blog called Dental Tech Tips, where we focus on the latest and greatest of dental technology. So if you'd like to find me in all the usual places online, you can search at Dental Tech Tips and connect with me that way. So let's go over a brief summary of what we're going to try and cover today in the roughly hour or so that we have together. We're going to start with a summary and introduction of the software and equipment involved in creating smile designs and digital diagnostics. We'll also have a look at the processes and highlight a few key steps involved with treatment planning and communication. And of course, we're going to be exploring some real life cases and scenarios that maybe you'll encounter yourself when working with digital diagnostics. Finally, of course, we're going to spend maybe 10, 15 minutes at a Q&A session where we can just take a moment to discuss, any questions related to today's topic, or even if it's related to, general smile design, diagnostics, or anything else in terms of 3D printing or digital dentistry as a whole. So I always like to start my presentations off with a little bit of a background. That way we can lay down the groundwork for what we're discussing today. Digital diagnostics are treatment planning, outcome. They're all an outcome-based philosophy, right? So you want to take a facially driven approach. You want to tackle these highly aesthetic cases and cosmetic cases with an outcome-based methodology. So the technology and tools that we use today that are available to us today, they give us a great level, an incredible level of communication and collaboration between the laboratory, the clinician, and even the patient that's never existed before. And research has really found that nearly 65% of all humans are really naturally visual learners, which means that they really need to see something in order to retain that kind of information, right? So using something as simple as a quick two-dimensional smile design as a visual aid to really help you and show the proposal to the patient and show them what the proposed outcome may be, it's an extremely powerful tool for increasing case acceptance rates significantly. So transferring these mock-ups from a smile design to a 3D printed model, using that as a template for an intraoral mock-up, we can further increase these not only case acceptance, but also acceptance rates of a final delivered prosthesis or all these other products due to the proposed aesthetics and changes that the patient has already approved beforehand. And really, when it comes down to communication, improved communication, I can't emphasize this enough, but as technicians, we need to read the script. We need to communicate with the doctor. Almost always there's one chief concern or one chief complaint that the patient really wants to address. So we really need to focus on that. You may get a model, you may get a scan, and you may look at it and say, let's open the BDO, let's do crown lengthening, let's do all this stuff, full coverage crowns, this hero dentistry that you want to paste up online. But when in reality, all the patient wants themselves is, their two front teeth. Just like the Christmas song, all I want for Christmas is my two front teeth, right? So just the two single centrals may be what the patient wants. So we really need to focus on not what the case may need, but what the patient's desires and what the clinician has assessed. So focusing on the communication, we need to really rely on clinical examinations, the dental history, the patient medical history, and what the clinician has determined is a feasible treatment plan. And our job as technicians is to really just bring that vision to life. So when we talk about treatment planning and elaborating a little bit more, we're performing an aesthetic analysis, right? So typically the clinician will be doing this. Maybe they send us the patient to chat for like a shade consult or something like that, or they just send a model. But really the aesthetic analysis, we need to break down what makes a smile an aesthetic one, right? And as the quote here says in the middle that you can see there, beauty is in the eye of the beholder. And of course, beauty is very subjective. But after doing about thousands of these types of cases, I think there really is a science that kind of backs it too, right? So there are a lot of fundamentals and rules that we can kind of adhere to. As the saying goes, you learn the rules so you know how to break them properly. The other quote I have up here is smile with your eyes, right? So smile just isn't composed simply of teeth. For the majority of history of dental technology, us technicians, we're at the bench, you get maybe an articulator. If you're really lucky, you get a face pull record. But all you see is just some teeth, and they're mounted on a cast that really doesn't tell us anything about the patient's aesthetics. So what we need to do is we need to really factor in how the rest of the face acts in harmony with this smile that we're designing with the dentition, so we can achieve an overall aesthetic result. A lot of the stuff your older guys may bust out the articulator, measure planes, and want the cast at 10 degrees tilted downwards. They want that bongo point at 110 millimeters from the condyle, and they want everything lined up and nice and square, so you're able to set that up. Those fundamentals are absolutely important, and you really should learn all of those if you're going to tackle smile design, but I don't think that's what's important in today's treatment methodologies, in my personal opinion. What I think is important is that we need to look at the face. We need to use that as a reference for our aesthetic analysis. So we need to assess the balance of the incisal edges. We need to make sure that the teeth, each one individual teeth, are following their long axis and tilted in the proper distal direction. We want to make sure that the teeth appear symmetrical from one side to the other, that they're in harmony with the horizontal facial planes, and that overall the gingival, even you have to look at the soft tissue, you have to look at the lips. Is the lip low? Is it high? Is it medium? If you have a high lip line, that may hurt or break your design. So also taking into account the gingival levels, how those are leveled out, how the gingival zeniths are, making sure that they also follow that long axis, so you're able to have an aesthetic, harmonious design that looks not only good from the dentition, but also taking into account the soft tissues. We also need to look at proportions, so how the teeth adhere to some basic rules that hopefully we all know about proportions. I'm not a huge fan of sticking to this example here, the golden rule. I know some guys are hardcore about it, but in my experience, natural teeth really do kind of deviate from the golden rule quite a bit. But it's really good to familiarize yourself with the concept at least. And then again, you can kind of break the rules and figure out what works for you. Thankfully, a lot of these smile analysis tools and aesthetic analysis tools come as visual aids in the smile design software and diagnostic software that we'll be talking about in a bit. So when it comes to smile design, you have a whole host of different software packages that you can use today. So you have 3Shape Smile Design, DSD, ExoCAD Smile Creator. You can even use Photoshop. It doesn't need to be a dental specific program. You can even use MS Paint that comes with your computer, as long as you're skilled enough and you know how to do it. I'm not going to touch too much on DSD because Asika actually has had a really great webinar this past October with Dr. Yasmin, where he spoke about DSD and how he applies it to clinical practice and everything like that. So you can just hop on YouTube, Asika Live, find that channel there, and you can watch this 1 hour talk. That was really great. It just gives you goes really in depth into DSD. But I will sprinkle a couple of things. As for my personal experience with smile design, back in the day, and kind of how I started was I just grab a picture from the doctor, throw it into Photoshop, and you just cut out the tooth, mirror it, and I think you can really appreciate even just seeing this. This is just a quick grab, highlight, select, copy, mirror, and you're able to see immediately what kind of results you're able to get. So again, not fancy software, not something you need to pay for. This is just simple photo editing software that you can just copy over and go back and forth. And the patient appreciates right away what kind of drastic change they can get. So it's really a matter of just using the tools that are accessible to you. So my tool of choice today, of course, is 3Shape Smile Design. But all these tools that I've discussed are really for patient excitement, right? So I've noticed quite an increase in case acceptance rates when we start incorporating smile design and diagnostics in our tool, in our arsenal for treatment planning. So this case up here is for Jenny. It was done with the wonderful Dr. Effie Hatcha. It's been one of my favorite cases that we've done recently. Jenny presented with, of course, a lot of attrition, severely overclosed bite. She just generally wasn't happy with how her teeth were creating this kind of overall aged appearance for her. So that was her chief concern. So we'll look at her case a little bit more, but again, like when you get this, you take it in, you bring it into smile design, but we'll discuss kind of how her case progressed a little bit more later on. But kind of elaborating a little bit more on smile design specifically, all you need to really get started is, already in your pocket, right? You just go ahead, grab your cell phone. The dentist just needs to snap 2 pictures and off you go, one full face and one retracted. In DSD, of course, they're a little bit more comprehensive in the fact that they incorporate 3D scan as well. But really a high quality photo when it comes to 3Shape smile design with some cameras, with just your cell phone camera is plenty enough. One really quick dental tech tip here is to make sure that the patient's head is level, right? So when you look at it here, that they're not tilting forward, tilting backwards, just because that introduces perspective distortion between one photo and another. So when you're trying to align these photos, you want to make sure that their head is very level with the camera. So you want to make sure, take a little bit of care, make sure that you're looking at them and tell them, you know what, keep your head nice and straight. Take one photo, put the retractors in, take the next photo. It'll give you much more accurate results. And I really need to emphasize that 2D smile design, again, it's arbitrary, right? It's more like an arbitrary cosmetic only program that's primarily used for patient segment. So you prepare your photos, you go into the software, follow, it's really kind of like paint by numbers more than anything. So you overlay the 2 points, you align your full face and retracted photo, use the eye points for the intraocular line to establish a nice horizontal plane. And then the software just kind of guides you through each step, and then at the end it spits out these images and videos that you're able to present to the doctor or even send them directly to the patient. And the doctor can use this as a second consult with them. And pretty much every large case that we get in the lab nowadays, it begins with a smile design, right? Because it's quick, it's easy. I can usually do these in about 10, 15 minutes. And we don't charge too much for them either because, it's really no harm, no foul. The patient doesn't go for it. At least, you haven't spent too much time. And then this way, everybody knows that there's not too much commitment on either end. And when doing this, I do see case acceptance rates boosted quite a bit. When patients see their actual face with the overlay and how their smile can look, they're all typically very eager to go on to the next step. And of course, the next step, of course, is once we get that green light, is take that smile design console, all those images. If they want any modifications, you can very easily go back into the software, make any modifications, do a second revision if you need to. But if they're happy with it, what I do is I'll just take those smile design images, I'll merge them into a 3D digital diagnostic in 3Shape, and then we'll proceed with the next console where you can either do a mock-up, intraoral mock-up, or present them with 3D models and some kind of a little bit of a video or something just discussing what we think our treatment plan needs to be. And the digital diagnostic is really one of the most powerful tools in my arsenal today as a technician. Believe it or not, I spend the majority of my time in a day as a designer in doing digital diagnostics. Again, if in DSD, they have these protocols where they have 2 steps in one, where you can have a motivational mock-up, all these different types. So if you're familiar with DSD, they have a bunch of different models. For my personal workflow, what I like to do is I like to incorporate kind of as many of those models into a single one as possible. I think it makes it a little bit more efficient. If you're doing like a fully additive case, that's a little bit easier. If it's a little bit subtractive, maybe you need to make a couple more models. But in terms of actually doing the diagnostic, at this point, you're able to actually see the dentition, right? So you're able to see the function. You're able to take into account the actual spacing of the teeth. Often with just a 2D smile design, again, it's very arbitrary. You don't really see maybe some of the stuff in the distal areas, in the posterior, in the lingual area. So now you're able to overlay some teeth. You're able to put it on there. And with this 3D smile design, with 3D diagnostic, you can also overlay those smile designs that you had approved from the patient. So, but regardless of methodology, whether you're using DSD, whether you're using 3Shape smile design, CAD smile, or whatever you may be using, the whole point is you want to get all this data together and kind of funnel it down and bring it in and distill it into the next step, which is, getting to the patient mock-up and then proceeding to either a provisional or, going straight to product. So of course, in 3Shape, we make these diagnostics by selecting a digital impression. Doesn't matter if the object is a scan file or a digital impression or a model. The actual object is just a variable, so don't get too tied up on the name. What matters is the container that the program is asking for, and then you supply that container with what it's looking for. So in this case, the whole reason why we choose that is so we're able to select a digital model. So if you don't have digital impression selected, you're not going to be able to build a model from it. So once we have it switched to digital impression, you're able to select model, and you're also able to define all your other indications. So of course, now you're going to select your teeth. Typically, I'm doing a full arch on all of these. So you'll select all the teeth by shift clicking, going to temp on prepared model, bridging all these teeth together, and of course, making sure that you're able to select a model that you can build. So at this point, if you've already scanned your models and you're switching it from a scan model to a digital impression, they may ask you if you want to rescan. I hit no and then just hit OK and proceed through. And then now we go ahead and make our smile. And the reason that I use temp on prepared model is because it's really a streamlined kind of way to really do a digital diagnostic. You don't need to set margins. You don't need to set individual margins. By bridging it all together, you're really only setting in one direction, so that saves you a lot of time as well. It's very fast, and all you need to focus on is the aesthetics, the proportions. If you're opening the BDO, the function, maybe you want to build in some canine rise between the upper and lower. And if you're really proficient with the software, I can knock these out in about 20 minutes, right? No need to worry about die space or cutting things back. Maybe the margin gives you an error. It just allows you to proceed through the design in a very kind of seamless way. And you're just worrying about aesthetics, function, and just presenting to the doctor, hey, you know what, this one needs a little bit more aggressive reduction, this one needs a little bit more, maybe we need to consider ortho, maybe there's some kind of soft tissue augmentation. And you can really analyze and play here without being discouraged by errors or trying to account for all these margins of contact that you would with a lot of these other free-shape indications. So doing diagnostic wax-ups by hand back in the day, you were basically stuck with whatever style you as a technician were capable of producing. So these pictures here, I'm regretfully putting up because at the time I thought they looked fantastic, but looking back at it now, they're not really that great, to be honest. But again, that was what I was capable of producing so many years ago. And I remember having to do these by hand, and maybe on that number 2-1 or number 9, and using the American system, maybe you get hung up on maybe the way that it looks there. You keep that tooth, not necessarily because it looks good, but because you spent some time on it, right? And you kind of build the rest of your wax up around the aesthetic of that tooth. And it looked okay, but it's not as good as it could be. And going back, like the way things were done traditionally, it takes a lot of time to do these things. So there's a lot of investment, a lot of emotional investment. You get attached to these cases. And they don't look as good as they could. Whereas if you're doing these things digitally, I find the work that I produce is much better in a very objective manner. Because if I don't like the way that tooth looks, I can cut it off, sculpt it 15 different ways, and maybe it goes haywire. And I go, you know what, I did like what I did previously. You just hit Control-Z, undo 15 times, and go back to exactly where you were. And that's no harm, no foul. It makes me much more efficient. And it makes things much more predictable. And also, I'm able to steal these libraries from all these great technicians that I have really no business pretending to be as good as, right? So I'm using a Nondas library, a Leacoff library, whoever's library. My results that match this specific patient are much better than what I can produce by hand. So again, we can overlay some pictures with that 2D smile design. We merge it all together. The patient's already approved the smile design. We try to get our 3D diagnostic as close as we can to what the patient's already approved. And the way we achieve that is we use the RealView engine inside of 3Shape. So what RealView does is it allows you to overlay the 3D model by selecting some unique points that are common between the 3D model as well as the smile, right? So you take the image of your smile design with the overlays, but you can still see the teeth. You bring it into the software and then you start cutting the teeth, the lips and everything out, mark some, I think, 4 points that correspond between the picture and the model. And then, of course, you can overlay your design and say, you know what, I have a little bit of a cant that's going up this way. Maybe the patient's midline is skewed this way. So we can rotate it. We can say, oh, you know what, this tooth shape, I liked it for the teeth because that's how their teeth have worn down over the years. But looking at their actual face, maybe they need a more ovate style or more triangular, whatever you may prefer for that patient, right? Or it needs to be a little bit closer to what the smile design was. And with these digital diagnostics, I'm approaching the case from a very prosthetically driven mindset. Nowadays, I design what the final prosthetic would really look like, right? So using prosthodontic principles, understanding what the clinician is hoping to achieve. And we adjust this diagnostic in a the mouth, right? So once it's done, it's sent to the clinician, they're able to adjust it in the mouth. Again, if you're familiar with DSD, you can be looking at a 3D functional pre-treatment, what I think they call it, and also a 3D functional post-treatment model. So that's how they produce it in DSD. And also they produce a 3D motivational model, which is one that's kind of ideal with none of the original teeth sticking through it like that. In my personal workflow, and especially with like printing in a SIGA, I find that you could probably achieve a lot of those without three models necessarily. You could do it really in 1 or 2. Again, it really depends on just how much tooth structure needs to be reduced or added onto and what kind of outcome we're expecting. So if it's only minor cosmetic changes, I can add just a little bit and print that off. If it's more drastic, then I'll produce a few different models. Maybe even I'll give the doctor a few different options. And that's really the power of 3D printing, right? If I want to do one with a square style of teeth, and then I go, you know what, I'm going to save that cam, build a model for it. I'm going to copy my order, and then I'm going to make a triangular looking one. And I'm going to make a model that you can print both of those. And it takes you, 20, 30 minutes in the Asiga. But if you're doing these by hand, you're waxing these up. And if you want to wax up a second set, that's going to take you twice the amount of time. So really these things, they scale quite a bit. They scale very well as well. And also for virtual diagnostics, I also take a very multidisciplinary approach, right? So typically we try to go with a treatment nowadays that's very minimally invasive because of the tools that we have available to us. So I always try to go very conservative in terms of what my recommendation is for reduction. So a lot of times my first suggestion isn't even anything that's restorative. It's typically ortho or something like that, right? So I'll show the doctor and say, you know what, these teeth are in alignment. Maybe we do a little bit of Invisalign or some kind of clear aligner solution that we're able to provide. And then the doctor is able to move those teeth just a little bit, maybe to do a little bit interproximal reduction, just to get those teeth a little bit closer to the final position that we want for the prosthetic phase. And of course, also, maybe they need tissue augmentation, maybe they need crown lengthening, something like that. So again, you kind of consult with the doctor. There's a little bit of back and forth there, and I'll kind of show you a case where we did that. So in this example here, we had a patient. Doctor determined that she's going to definitely need crown lengthening, right? And I looked at the DSD of the smile design, and I said the same thing. So of course, we present her with a 2D smile design, and the patient goes, okay, I like the way that looks. So of course, the next step is to refer to a periodontist, in this case, because the doctor just felt more comfortable with that. So what we did was I took my design, I overlaid those gingival proportions. I sent this CAD design to the general dentist as well as the periodontist. All three of us, we got on the phone at the same time, or Zoom meeting. I think it might have been a Zoom meeting at that point. And we go ahead and say, you know what, this is how much I think it's gonna look good based on my arbitrary cosmetic assessment of the case. And of course, the periodontist knows better than me. That's not clinically feasible. He says, you know what, you're violating the crown to root ratio too much on these 3 teeth here. Back it up a little bit, and then send me another proposal. So we could do this live, or I could take it, do a couple revisions, send him another one for review. And the nice thing about this is all 3 of us can see the case at the same time. So we're all looking at it. We're all collaborating in real time rather than some scribbles on scripts. 3 weeks later, you get to it and you go, oh, well, what did the doctor want here? And with this, you're able to get real-time feedback, and we're able to get a much more efficient workflow, a much more better result. So of course, once the periodontist signs off, back in the day, what I did was I would use a custom tray module to create these reduction guides, the crown lengthening guides. What I do nowadays, actually, I find is that the edges of these custom tray ones weren't really that accurate to where they wanted the final crown lengthening proportion to be. So what we do nowadays is we actually just use a suck-down thermoform and just make a clear Essex retainer with some windows that we cut out, and we send that, and it's actually been a much better result. I'm a huge proponent of doing things as much digitally as possible, but sometimes doing things the practical way and in the most efficient way is a little better. So something like this nowadays, I'm actually doing these crown lengthening guides just out of a clear suck-down material. So of course, the patient goes through the crown lengthening process, everything heals up nicely, and now it's time for us to 3D print some temp shells, provisionals, and actually I made some prep guides as well for the doctor, right? So do I go about this like a caveman and duplicate things and create orders from scratch? Of course not. I just go into 3Shape, duplicate my orders and change things a little bit so I get all these different prep guides, give myself the temps, get the doctor everything. Super easy for me. The printer's doing all the heavy lifting and I just look like a superstar, right? So I'm not going to really go too much into this portion because we're more speaking about the diagnostics and smile design, but I feel like it's good to showcase kind of the case from beginning to completion. So once we finish this, I'll just kind of fast forward. She healed up pretty nicely from everything. These are the final results here. We had the final prep scan. And we ended up making a night guard for her. But again, I just copied and pasted my original arbitrary design with that smile design. And it wasn't exactly what we had on the 2D smile design, but it's very, very close to what we had initially planned. And the patient was extremely happy with the result. And it was super easy, super predictable. And all it started with was a cell phone picture from the doctor casually on a Thursday night. He goes, yeah, I saw this patient. What do you think? Got a very great result, a year later on. So another example here actually of this time incorporating a 3D face scan instead of pictures, and just demonstrates how we use temporary on prepared model, again, for a preliminary design, right? So this time we set up the diagnostic as a temp on prep. This is, fully partially edentulous, but we treat it basically as fully edentulous for implant retained purposes. And I just go ahead and use this order and I just add one additional pontic, usually like a 7 or 8. And you put it back there and you use that as a special object for your tissue. So you design all this stuff, design your gingiva. And the reason I do this rather than using a traditional implant workflow is because number one, the implants are buried. But number two, temp on prep, like I said, it's very free form design. You're able to just focus on the aesthetics, the function, how everything flows. You just make this big giant pontic for the gingival, and then you're able to sculpt it as much as you want. It's not going to give you any errors of, well, you didn't just define the spline wide enough for the implants to be accommodated, or there's less holes than expected. And those are very common errors that you encounter with 3Shape when working with any kind of gingival workflow. So again, once this is done, I can, of course, convert this into a 3D printed provisional for the patient to wear. I can convert this into my final definitive design if we're brave enough to go without verification. I rarely ever do, so there's always verification, a bit of back and forth, but I think it just kind of shows how powerful temporary prepared is, and pairing it with not just a 2D face, a 2D photo, but also 3D face scans. So in our design, I assess all this stuff. The doctor can, of course, adjust the prototypes. We're able to adjust it after the fact. I'm not going to speak too much about this workflow, but I speak about it quite a bit in some of the lectures. If you're interested in seeing how we copy and paste and all that, send me a message after the fact that I can send you a link to one of my previous lectures where we discuss kind of the copy and paste methodology. Dental Tech Tips at gmail.com. So now, of course, we have our designs, we have our smile designs, patients accepted. What's next, right? Patients happy with everything. Consult went well. Pictures were, great, and everything so far has worked out very well. So, of course, we proceed to the next step, and that is, of course, 3D printing all these different indications. And let's look at how we transform these digital objects that we created in virtual space and turning them into real world objects via printing. I speak about this often. 3D printed models are typically a loss leader item in the lab because they're ultimately disposable objects, right? They end up in the garbage because they're used as something that you use to fabricate a crown, an appliance, a device, whatever it may be. 3D printed diagnostic models, however, are actually one of the few printed items that generally pay for themselves or break even, or maybe even we generate a little bit of a profit in the lab off of them. Back in the day, like when I was discussing about waxing these things up by hand, you couldn't really charge too much because, how much can you really build into a bill for something so large? So typically you're charging whatever it may be, $20 an hour, enough to cover somebody's labor for the amount of time that it takes, $20 per unit, what we typically build out for ours. And you're spending all day, if you're doing a full upper and lower, that's a full 8-hour day of waxing up. If you really want to focus on the details, typically it wasn't. Maybe you give it to a more junior technician, maybe to spend a little bit less time. Maybe the details aren't exactly what you want, but it kind of gives you the vertical and everything, and the general proportions of what you want to achieve. Whereas if you're doing these digitally, I have beautiful libraries. I'm able to knock out 2, 3, 4 of these in an hour. we're still charging that $20 per unit, and we charge a material surcharge of printing these models on top, $30 for the set, right? And that's just to cover kind of material overhead. But at that point, you're actually able to generate a little bit of a profit margin on top of this. So with this digital route, I'm whipping up full now diagnostics all day long. Everybody's happy. All this stuff looks fantastic. The patient gets a much more realistic representation of what is going to be the final. So it gives you more predictability, but also, it saves you a lot of time. So typically, most of these things, I print them in just regular old vector model, very reliable, great results. But nowadays, you also have these, if you have clients that are very particular, they like to have ortho-style models with these beautiful bases. They do look very nice. If you have clients that are kind of sticklers for detail like that, Asiga does have Dentist Study, which has like that white ortho model, beautiful finish, so you can print out your models like that. They also have Dentiform. So just like I was speaking previously about making crown lengthening guides via custom tray module, nowadays, like I said, I just print them out in Dentiform. This way, you just use your suck down thermoform model. This material, it withstands heat. It's very resistant to any kind of deformation. It's specifically engineered to kind of resist all those things. So great materials. You can use these for a lot of the applications. One other thing I'm going to kind of speak about, of course, is when you make these indexes, right? So if you're making any indexes, some people prefer silicone matrices. Some people actually prefer to do, again, suck down thermoform with teeth. So using Dentiform, you use that with the fully mocked up model. It's a great material. Try it out. So of course, you just grab all your files, hop into a Asiga Composer, choose your printer that you have on there, load your material, and load all the files that need to be printed, and you just distribute them onto the build platform. Generate some supports, and really it's just sent off to the printer, and in no time at all, you have your models ready to go. And I really wish I had more to say here about the Asiga Composer, but it's really a streamlined process to get things started printing, and the software is both user-friendly, but it has enough control that if you want to open up some very advanced tools, or if you want a little bit more control over certain aspects of the printing process, you're able to do that. But I mean, it's really just press the button and go. I wish I had more to say about it besides that. Put your models on there, so make sure they're supported well, and make sure you have all your options selected properly, and off you go, right? So once you have these printed models, 20, 30 minutes sometimes it takes just for a full arch. You need to make a template, right? So I spoke about this already. My preference, of course, is like a silicone index. But if you prefer to use any kind of suck down thermoform, use Dentiform. I think it'll give you a little bit better result than Dentamodel. And there's pros and cons to both. So if you're using a light cure only type of composite or something like that, then you're kind of relegated to using a clear suck down thermoform. They do have clear silicones as well, but they're not quite fully transparent. They're like a little bit translucent, but you'll get a little bit of light in there. If you're using more of like a dual cure material, then of course, silicone matrix, I find it reproduces surface detail a little bit more. And especially now with my diagnostics, you get a lot of surface texture, a lot of incisal details that you really want to replicate and show the patient. So of course, that case that I spoke about earlier, Jenny, you can really appreciate what the models printed off, how different it was from her initial models to what we had mocked up here. And the effort that kind of went into planning this case, opening the BDO, making sure that everything would work out very well. We did some crown lengthening as well. I think we patterned provisionals for 6 months. But yeah, the here is to really, show the patient that what changes are possible, right? So then, of course, once we do that, we fabricate our silicone indices, matrices, and some marking these things up in the mouth. And pretty much instantly, you can see the changes from before to after. They're very drastic, and the patient was just absolutely thrilled. Of course, she saw this. She was just absolutely thrilled. A much more youthful appearance, restored VDO. On the lower, she was showing much more teeth. Looking in the mirror, a lot of patients, the moment they see this, they're eager to get to the finish. They go, how do I do that? I want to look like this. So it just, our case acceptance rates go through the roof when following this kind of methodology. So as you can see, with smile designs, digital diagnostics, and all the tools that we kind of have involved, they really help with increasing case acceptance. With a 3D printer to help you really transform those digital designs and bring them into life, bring them into reality, like the printers by Asiga, of course, it really helps you to deliver highly predictable and aesthetically pleasing results. And with that, I'd like to say thank you again to Corey, Graham, and the whole team at Asiga, everyone who's joined here today to listen in. Hopefully you've picked up some valuable information that will really help you in creating aesthetic smile designs and diagnostics. And if there's anything that you want to discuss, continue the conversation online after the fact, send me a message, send me an email at dentaltechtips@gmail.com or anywhere via social media. More than happy to keep the conversation going. And with that, I'd like to say thank you and maybe take some questions that may have come in.
Absolutely. Thank you so much, Min. I really appreciate it. That was a phenomenal presentation. Before, while we're waiting for any questions to come through, can you jump back to the before and after photo of the patient?
Yes. So this is the before. And this,
I mean, just look at the overall confidence level and change. I mean, I mean, you know, she was ready for the second photo. I mean, she got a little more makeup on, maybe perhaps, but she got her hair done a little bit. But just the overall confidence in her eyes and how happy she is with her smile. I mean, just look at that.
Yeah, and even if you look at the composite mock-up, you know, it's not perfect. There's a little bubble in there. The margins aren't fully sealed or anything like that. But it gives you such an instant appreciation for where it's headed, right?
Yeah, that's phenomenal. So you know, what do you think I guess prior to what you may have always offered diagnostic design for your patients and for your clients, but do you have an idea of like what your percentage of acceptance is when you actually do this case planning prior?
I don't have hard numbers,
Yeah.
unfortunately, because it's so rare in the lab for us to really see the results, right? Because like the doctor will I'll have case plans sitting there for 6 months, or actually I have 2 or 3 right now. It's like 2 or 3 years later, and the doctor says, you know what, the patient wants to go for it, right? So it's very difficult for me to gauge how much it was before doing these traditionally versus now too, because the other thing is we've grown a lot in the past few years too.
Yeah.
It's not really a percentage wise. I will say that I do notice a growth. I'm not sure if it's necessarily as a direct result of this, or it's just kind of complementary to it. But I do feel that there is an appreciable amount of increase in case acceptance due to this.
Yeah. Now, do you charge for your diagnostic design if they don't accept it still?
Yes. Okay. Always. So typically my DSD, it's like less than $100, whatever it is. Just like a quick motivation, right? You tell the doctor, listen, snap 2 pictures. You don't have to do anything. If you want to take a scan just for the sake of having records. The patient's there anyways. They snap the pictures, they send it to me. We do a quick smile mock-up. They don't even need to see the patient nowadays, really. You just send them via email. The patient opens it up and goes, wow, that looks great. If they want to bring them in, the doctor's there. They can present and kind of explain a little bit more what clinically may be done, maybe a little bit more so the patient has a bit of an understanding. But again, visually, just seeing yourself, okay, well, this is what it is and this is where it's going to be. It's huge. It's very huge.
Yeah. Oh, I'm sure. And I'm sure by offering this diagnostic, this wax up design for your doctors, I'm sure that only increase that communication channel between you and your doctors as well.
Oh, absolutely.
Because instead of just, doing the run of the mill bread and butter crown and bridge cases, by doing these more extreme cases or more advanced cases into this detail, I'm sure it probably had an increase, a level of respect between you and the doctor and communication overall.
Oh, it's an excellent relationship builder for sure. In terms of constantly picking up the phone, shooting a text to the doctor, maybe you hop on a quick Zoom call, maybe, you're chatting back and forth how to tackle the case. Anytime you have exposure to a client, it's an opportunity to build that relationship, right? And if you're able to deliver consistently as well, then that's just the icing on the cake.
Awesome. We got another question that came through. It says, have you tried any materials for printing permanent crowns yet on your Asiga printer?
I've tried quite a few. the jury's still out, in my opinion. I think that the engineering on the material side needs to get a little bit better. I'm always kind of skeptical just because I've been burned quite a bit in the past by too many marketing promises. But things can only get better. A lot of the new ones that are coming out today, they're very competitive. The numbers look very promising, but it's all lab controlled tests. Once you get it inside a patient, that's the true test, right? So 6 months down the road, 2 years from now, we'll really see what the results are, right? That's kind of my take on these permanent crown resins at the moment.
Yeah, absolutely. That's a very good point, that there's still a lot of research that's happening, and the chemistry is always evolving. I mean, we see new resin come out almost every week, it feels like, doesn't it, man? I mean, it's like literally,
it's a hot market for sure.
Yeah, and we're right around the corner from Lab Day Chicago, and so I'm sure we'll see some announcements there, and same like right before, like it seems like right before Lab Day Chicago hits and CDS hits, or I mean not CDS, but IDS hits, there's always some sort of announcement for some new materials, and so I'll be excited to see what we have coming around in a couple of weeks. And just so everybody's aware, if you guys are attending Chicago, Min will be speaking for Asiga there as well, talking about the multi-range printing capacities with Asiga. And so that's an extremely exciting topic in not webinar, but seminar that Min will be putting on.
Let's do a little video here.
Yeah, I saw that sneak in.
A little sneak peek. I snuck it in there. I figured it was a good little thing here of the multi-range, multi-stack, all the cool things that you're able to do with the software, right?
Absolutely.
Yeah, I'm looking forward to that one. Thank you to see you again for
it's going to be a lot of fun. It's going to be a really good show, and it's extremely promising. And then from there, just overall start to finish, what would you expect a time to design and deliver this case for your doctors? How much time do you feel like you have devoted per diagnostic?
So are you talking to the finish, or are you just talking to this kind of diagnostic phase?
So let's say starting from actually taking the patient in, getting the photo, doing the virtual smile design, and then moving all the way through the design into printing and post-processing. What do you think this start to finish? Let's say they do accept the case, because we already see, I mean, you wouldn't be doing this if they didn't accept the case, increased case acceptance. And so what, for our viewers, what do you think that overall time would be, you think?
So we have typically a turnaround time of about 2 weeks on these types of cases, because I do like to spend a little bit of time on it. You can get these diagnostic. My personal hands-on time of the design, I'd say a smile design, if you're very proficient with it, 10, 15 minutes.
Wow. Yeah.
If you're doing a full mouth, I'd say if you're a beginner, upper and lower, I'd say set aside 4 hours just to really get things proficient. The nice thing is, of course, when you design these, if you're doing a full mouth, you only need to design half. You need to design from the first quad to the central incisor, and then the lower fourth quad, let's say, back, right? And then what you do is you're able to just mirror that on the other side. Yeah. So that saves you a lot of time if you're able to figure out how to play with the design to get that done. I can do these 20, 40 minutes.
Wow.
I know my library very well. I have a custom library that's very quick. It has very good average proportions that I'm very happy with. I think fits a lot of patients. So I use that library quite often. 40 minutes, I have it done. You send it to the printer. You're doing other things in the meantime. It's hands off, but it's 30 minutes to print the model. And then it's just silicone matrix, put it on there, let it set, cut around the gingival. So another 5 minutes there, and deliver to your client, right? So I mean, it's maybe a full day's work versus, back in the day where you're spending 2-3 days on just a wax up and.
Yeah, absolutely. So I just had a question come through for the, what printers from Asiga would you recommend using for this?
So my personal preference, because we do so much dental model, is of course the Pro 4K. If you're just starting out and maybe you're a little bit smaller, I'd say the Max is a little bit more nimble, a little bit more agile in terms of stocking different resins. So just keeping a small bottle of dentist study, let's say, and your client wants white ortho style models. You don't need to have this big giant tray that you fill up with 10 liters of resin. You have 5 bottles sitting in the, you have just one nice little 1 liter tray, pour it all in there. You can print a whole bunch of models with that, switch out materials. It's a little bit more versatile if you're just starting out. But if you have the volume and you could just toss a diagnostic in with all your other stuff, then I mean, dental model on the Pro can.
Yeah, that's good. That's good. So yeah, so it's the you can do either of these type. I mean, this whole workflow on either the Max or the Pro 4K, but depending on the volume, you may want to look at either getting the Pro 4K or settling with the Max. Absolutely. So this is great. I don't see any other questions coming through. Thank you, Min, so much for your time, and thank you all to our viewers for taking time out of your guys' busy day in joining our webinar. Once again, this has been recorded. We'll be posting it on YouTube here in a couple of days. Also, this does qualify for CE for RGs and CDTs, and that is recognized through the NBC. So once again, thank you, Min, and thank you everybody for joining.
Thank you, everyone. Thank you, Corey.
Absolutely. Take care. See you guys.
See you.